Hello everyone. Welcome to the Archive Radio Show. Today is Thursday, July 2nd, 2026. I'm your host, Atypical ASR. Are you all ready to put on your thinking caps today? And today we have a very special and important topic to talk about. It is all about how computers listen to us. Especially when we do not speak perfectly smoothly. As your friendly radio teacher, I'm so excited to share this with you, because it touches on how we can make technology kinder and more helpful for everyone. The title of the paper we're looking at today is What Counts as an Error, Dual Reference Benchmarking for Atypical ASR. The curl is chaps://stashartsit.org/abs/2606.31121v1. Wow, that is a very long title and a very long web address. But do not worry at all. I will explain it so it is super easy and fun to understand. Let us start with a simple question for the class. Have you ever used a voice assistant like Siri or Alexa? You talk to it, and it magically writes down what you said or does what you ask. This amazing technology is called automatic speech recognition, or ASR for short. For most people, it works pretty well most of the time. What if someone has a stutter? A stutter is when someone might repeat sounds or stretch out once, like saying I want to go. These computer systems often get very confused by this kind of atypical speech, and the smart scientists who build these systems have a big debate going on. When the computer writes down what the person said, what is the right answer? If the person says, I want to go, should the computer do exactly that? Or should the computer just write, I want to go, without the extra sounds? This paper says that both answers can be correct, depending on what we need to do with the text. What researchers call these two different ways, intended and verbatim. Intended transcription is when the computer cleans up the sentence for you. It removes all the repetitions and extra sounds. It's just what verbatim transcription is when the computer writes down every single sound it hears. It includes all the stutters, repetitions, and filler words exactly as they were spoken out loud. Or in the past, scientists would just pick one of these ways and say their artificial intelligence model is the best. But that is not really fair, is it? Because the best model for one job might be terrible for the other job. To figure this out, the researchers tested 11 different speech recognition models. They compared how well they did on both the intended and verbatim tasks. And guess what they found out, class? They found our different types of artificial intelligence are good at completely different things. Models that predict the next word based on the whole sentence, called regressive models, are really good at intended speech. They can guess what you meant to say and magically clean up the sentence for you. But models that look at the sound moment by moment, called models, are much better at verbatim speech. They act like very careful listeners who write down every single little sound they hear. I've also found that stretching out a word, which is called a prolongation, is actually easy for the computer to understand. But repeating parts of a word, like saying bureaucratic, is very hard for both types of models. Let us talk about 3 specific ways this research can change our everyday lives. I promise these examples will show you just how important this science really is. First, let us think about voice assistants and dictation software. Imagine a person who stutters is trying to write an important email to their boss using their voice. They do not want the email to have all their stutters typed out on the screen. They want the computer to use the intended transcription to make it look smooth, by knowing which artificial intelligence model is best for intended speech. Companies can build better voice keyboards. This means people with atypical speech can send messages smoothly and quickly without feeling frustrated. This will make technology much more accessible and friendly for everyone in their daily work. Right. The second example is in the doctor's office or speech therapy clinics. Speech therapists need to know exactly how often and in what way a person stutters to help them properly. If the computer automatically cleans up the speech, the therapist cannot see what the person actually said. So, for clinical tools, we absolutely need the verbatim transcription. Using those moment-by-moment models, we can create automated tools for therapists. These tools will write down every repetition and pause perfectly without anyone having to type it by hand. This saves the therapist hours and hours of boring work, and helps them track their patients' progress so much better. The third example is for inclusive education in classrooms. Just like ours. Imagine we have a smart classroom that takes notes for all the students automatically while they speak. If a student who stutters is giving a big presentation, The system needs to be smart enough to handle both ways. It can give the verbatim transcript to the teacher to help understand the student's speech development and build confidence. But it can provide the intended transcript for the class notes so the other students can read the main ideas clearly. This dual reference idea means nobody is left out and everyone's voice is respected exactly how they want it to be. Let us dive a little deeper into the science of how they measure the errors. Usually scientists use something called word error rate to see if the computer did a good job. Word error rate basically counts how many words the computer got wrong, missed, or added by mistake. But the paper points out a massive problem like this traditional math. If a person says 20% environmental, and the computer types out the number 20 instead of the spelling for 20, the word error rate says the computer made a huge mistake. Even though the meaning is exactly the same, the score looks very bad. This is especially tricky for intended speech recognition. When the computer tries to guess the meaning, it might use slightly different words. So the researchers looked at newer ways to score the computers using semantic metrics. These are special tests that check if the meaning of the sentence is correct, not just the exact spelling. Yet even these smart metrics have blind spots that we have to watch out for. For example, if the person meant to say, "You are a bully," and the computer hears, "You are bullied," the meaning is completely changed, and the score needs to reflect that this is a very bad mistake. The researchers proved that we cannot just rely on one single number to grade these systems. We have to look at the whole big picture. Let us also talk about the specific types of stuttering events they studied. They used a very special dataset that was carefully labeled by clinical experts. They looked at things called syllable repetitions, where a whole syllable is repeated over and over. Or incomplete syllable repetitions, where just a tiny part of a sound is repeated. In multisyllable unit repetitions, where whole chunks of words are repeated. They found that when models try to clean up the speech, they often insert totally wrong words by accident. They try so hard to make the sentence make sense that they just make up new words out of thin air. On the other hand, the models that try to copy every sound often substitute words incorrectly. They get confused by the incomplete sounds and guess the wrong letter entirely. This detailed breakdown is so incredibly helpful because it shows engineers exactly what they need to fix next. And why is all of this so important for human-computer interaction? Well, human-computer interaction is all about making machines work well for humans. It is not about making humans change to work well for machines. When scientists hide the fact that their model deletes stutters, they are making a secret rule about what normal speech should look like. Normal speech should look like. We are basically saying that studied speech is wrong and needs to be fixed. But this paper loudly argues that studied speech is just another completely valid way of speaking. By having two different references, intended and verbatim, we respect the speaker. We give the power back to the user to choose how their voice is represented in the digital world. If they want it cleaned up for a quick text message, the computer can do that easily. If they want it preserved exactly as they spec it for a speech therapy session, the computer can do that too. I think that is just wonderful, do not you agree? It makes the future of technology look so much brighter and much more kind. Thank you all for listening today, and I will see you next time on the Archive Radio Show.